Search OpenClaw, and you might find a 1997 platformer with a pixelated pirate cat. But we're looking at the framework that has overtaken that result. OpenClaw is a Node.js-based framework designed for executing background tasks autonomously. It rebuilds the way users interact with software by running as a system service rather than mimicking legacy game hardware. The average knowledge worker loses hours every week, toggling between dozens of browser tabs, disconnected project management tools, and sprawling messaging apps. Information is fragmented across a landscape of SaaS platforms that rarely communicate. OpenClaw centralizes that sprawl. It functions as a locally hosted control plane that connects directly to the messaging apps you already use, like Telegram or Discord. You no longer log in to a web dashboard. You simply send a message to your agent. Routing daily operations through a single local command center eliminates switching contexts. Solving this fragmentation requires moving from disconnected web apps toward a unified local node. Traditional AI tools are passive and stateless. You type a prompt, you receive a response, and the system immediately goes dormant. In contrast, OpenClaw is stateful and proactive, running continuously in the background as a relentless daemon process. This diagram compares models. Top, the standard linear input-output path. Bottom, OpenClaw's observe, plan, act loop, waking every 30 minutes to execute tasks. This continuous loop requires hardware. Heavy browser automation needs 16 gigabytes of RAM. Conversely, PicoClaw and ZeroClaw use sub-5 megabyte memory on $10 hardware. Enterprise AI capability is not determined by model size alone. High-level automation depends on matching the architectural framework, whether a heavy node process or a tiny Rust binary, to the specific hardware environment. Most commercial AI assistants keep their core instructions hidden behind proprietary vendor APIs. OpenClaw shifts that configuration directly to your local drive. The entire personality and operational boundary of the agent is defined using plain text markdown files. You dictate rules and constraints in a file called soul.md, while user.md provides the agent with context on your specific preferences and office hours. We can see these files in action within a practical morning command center workflow. Because the agent's core rules are set locally, it initiates its entire daily schedule without ever waiting for a human prompt. Long before you log on, the agent wakes up on its heartbeat. It triages unread emails, drafts suggested replies in your tone, and compiles a prioritized daily brief directly into your Slack channel. Defining agent behavior in local text files prevents vendor lock-in. It creates a reproducible, customized operating system that remains consistent regardless of which AI provider you use. Organizations often assume that giving an AI access to more tools automatically increases its problem-solving ability. In practice, the opposite is frequently true. This chart illustrates data from the SWE Skills Bench evaluation, showing what happens when you overload an agent with procedural instructions. Token costs spike by up to 451%, while the actual task success rate improves by only 1.2%. To solve this financial drain, OpenClaw implements dynamic tool search and prompt caching. Instead of injecting every possible instruction into the system prompt at once, it filters and fetches only the specific tool schemas required for the immediate task. Loading tools lazily reduces the total number of input tokens sent to the model. This preserves the effective context window for actual reasoning while keeping API costs within a defined budget. But technical efficiency does not solve the problem of high-stakes autonomy. Organizations that focus purely on saving tokens often over-delegate tasks that require nuanced human judgment. We see the results of this over-delegation in the Klarna effect, where automated systems resolve issues rapidly, but fail to manage the complexity of frustrated users. ROI in AI agents is achieved through strict context efficiency and by delegating only appropriate triage tasks. The value lies in filtering the high-volume noise, not in removing human oversight from the final decision. Giving an autonomous program direct system-level access to your local files removes traditional security boundaries. The agent becomes an execution vector for anything it reads. This diagram shows an indirect prompt injection attack. A seemingly harmless PDF arrives in an email, but it contains a hidden text layer instructing the agent to forward sensitive data. OpenClaw counters this by isolating untrusted payload content from the core system prompt. Even with payload isolation, the system relies on a hybrid judgment architecture to prevent catastrophic mistakes. The framework is designed to verify intent before taking destructive action. This is controlled by the exec.ask setting. When enabled, any high-risk operation, like deleting a directory or sending a payment, triggers an interactive card in your messaging app, pausing the entire workflow. The agent still does the high-volume work of sorting data and staging the action. But the process physically halts until a human operator clicks Approve. Safe autonomy requires structural friction. Inserting human checkpoints into the execution loop is a mandatory security feature for enterprise deployment, ensuring the machine never acts without authorization. Moving toward a local agent framework leads to a specific, critical result: absolute data sovereignty. This diagram shows how OpenClaw bypasses cloud vendors. By routing the framework's requests directly into a local model, like Ollama, the entire operation remains secured within your own infrastructure. In this local setup, zero sensitive company data ever touches an external server. Your proprietary communications and codebase are never used to train a public model. Transitioning from passive chatbots to active, hardened local automation changes how work is managed. The focus moves from asking questions to executing objectives. Deploying these autonomous systems provides the leverage needed to scale operations. It allows small teams to increase their output exponentially without increasing their headcount. To learn how to build and secure this infrastructure, subscribe to the Logic G Solution channel. We provide the setup guides and agent strategies needed to deploy these tools in the real world. Mastering local, autonomous tools is the definitive way to reclaim the workweek and maintain a competitive operational edge.